Today's goal is to add and subtract rational expressions. In example 1, we're starting off pretty easy. We already have a common denominator, so we can go ahead and combine the numerators. So we have x minus 3y minus x minus y all over 6y to the fifth. Now, I put that minus in, and I used a set of parentheses because I found the most common error students make is they'll forget to distribute the negative sign to all the terms in the numerator of the second fraction. So I like to take an extra step so I just don't forget. Okay, well now if I have like terms, I've got x minus x, well that just cancels out. And I've got negative 3y plus y, so that's negative 2y over. Notice when I added and subtracted the fractions, I just kept the denominator. Like if you eat a quarter of a piece of pizza and then you eat 2/4 of a piece of pizza, that means in total you ate 3/4 of a piece of pizza. The denominator didn't change when I add or subtract the numerators. Okay, at this point now I'm going to just see if I can simplify. Well, negative 2y means negative 2 times y, and 6 is 2 times 3. And y to the fifth means y times y times y times y. Expand it or don't, do if that helps you cancel. Clearly we can cancel the 2's because I'm multiplying by 2 in both the numerator and the denominator. I'm also multiplying by y in both the numerator and the denominator. So it appears that just the negative sign is left up top. So that's a negative 1 over 2y, in the denominator. I had y to the fifth, so y times y times y times y times y. So now I have 4 y's left. So I have negative 1 over 2y to the fourth. I was asked to list the restricted values. These are the same thing as their discontinuities. So I'm going to look in the unsimplified version. The only thing that would make the denominator equal to 0 is if y were equal to 0. So the discontinuity is y equals 0, or y can't be equal to 0. Okay, let's take a look at example 2. Now, to add or subtract fractions, I need a common denominator. So let's work on that first. 3p is just 3 times p. So I'll need both of those things. And p minus 2, that's already factored because it's a linear factor. So I'll need the 3, the p, and the p minus 2 in my least common denominator. This p minus 2, I like to think of as an unbreakable linear factor. Linear factors can't be split up. So even though I have this p here, that's different from this p minus 2 here because these guys can't break up. Okay, so I have this expression 2p over 3p, and I need in its denominator, the p minus 2. So I'm going to multiply by p minus 2 over p minus 2. Essentially, I'm multiplying by 1. Which you're allowed to do. It doesn't change anything. And over here, I've already got the p minus 2 in my denominator, so I need the 3 and I need the p. So I'll multiply by 3p over 3p. Again, that's like multiplying by 1. It doesn't change anything. Okay, so now that gives me, I'll have to distribute over here. So that gives me 2p squared minus 4p up top. I'm going to leave my denominator in factored form so that I can cancel out things later. Here I've got a 6p squared over 3p times p minus 2. Okay, any like terms? Yeah, I can combine these guys. And I end up with 8p squared minus 4p all over. When I add or subtract, my denominator stays the same once I have it in common. Okay, now I might be done here, or I might be able to simplify. To see if I can simplify, I need common terms that I'm multiplying by in the numerator and the denominator. So we'll factor out the common 4p. Well, I can cancel out a p, that's nice. And so, did it say, ooh, good, leave my answer in factored form. So all I have left is 4 times the quantity 2p minus 1 over 3 times the quantity p minus 2. Where p cannot be 0 or 2. Okay, let's take a look at this next problem. Express your answer in standard form. Okay, to figure out what my least common denominator is, I need to start by just factoring the denominators that already exist. Oh, nice. They both have something in common, so we'll just factor that out. So my least common denominator is going to need an x. It's going to need an x minus 3. It's going to need a 3. So I can just put that here if I want. Or some of you are going to write it like this. This would be the more common way to write it, but both are the same. Oh, good. I've already packed an x minus 3 in my denominator, so I don't need a second one. So when I'm getting a common denominator, I'm thinking to myself, I already have an x here. I already have an x minus 3. I just need this 3. So let's multiply by 3 over 3. In the next denominator, I'm thinking, cool, I've got the 3 this time, and I've got the x minus 3. I just need the x. So I'll multiply by x over x. Okay, let's actually do that multiplication. I'll have to distribute here, so I have 3x plus 9 over x times 3 times x minus 3 minus here, oh yeah, I'll have to distribute as well, so I have x squared plus 3x over 3 times x minus 3. Again, don't forget to distribute the subtraction sign to all terms in the numerator of the next fraction. So this really means 3x plus 9 minus x squared minus 3x all over 3x times the quantity x minus 3. Let's see if we have any like terms. We have negative x squared. I'm going to put these in order. These guys will cancel out. So negative x squared plus 9 over 3x times x minus 3. Now, negative x squared plus 9, it should feel sort of familiar to you because it's the opposite of x squared minus 9, right? If I factor out a negative 1, it's more obvious that this factors into the opposite of x times 3 plus x minus, the opposite of x plus 3 times x minus 3. If you factored up here as 3 plus x and 3 minus x, that would be the same thing. So either this or this would work for factoring the denominator, and good thing we did factor the denominator because we can simplify by canceling factors we're multiplying by in both the numerator and the denominator. It asked for our answer in standard form, so we got to multiply out now that we've simplified. So we have negative x minus 3 over 3x as long as x isn't 0 or positive 3. And one final example for you. Let's simplify. You guys know the drill by now. Let's start by factoring the denominators so we can choose an appropriate least common denominator. Our least common denominator will need an x. It'll need a 2. It'll need an x plus 5. Here we're missing the 2. Here we're missing the x. So let's multiply those. The type of multiplication you're doing depends on what you end up with. Which is to say, on the right we distributed, on the left we could just straight multiply since we only had 2 terms. Can't say this enough. Distribute the subtraction sign. So we have 2x minus x plus 2x over 2x times x plus 5 gives us 2, oops, I'm so sorry, this is x squared. So we have negative x squared plus 4x all over 2x times the quantity x plus 5. Up top we can factor out a negative x. Keep in mind in the denominator, right, this means 2 times x plus 5. We're multiplying both the numerator and the denominator by x, so we can cancel that out. We're left with, it doesn't say leave it in standard or factored form, so personal preference, you get to pick. Let's list out our discontinuities, and we're done. It would also be correct, of course, to present this as your answer. Same discontinuities. These are equally correct. Final answers.